Welcome to part 2 of my notes on volume of a rectangular prism. So today we're going to be looking at affecting the volume of rectangular prisms. And in our previous unit, we talked about a scale factor, which scale factor is the number that you're multiplying by. And today's lesson is going to give us the ratio of how to calculate the scale factor when you know either what the volume was changed to or what one of the attributes were changed to. And remember, attributes that we're going to be talking about are length, width, and height. So when describing the scale factor, we can think of setting up a ratio comparing the new measurement to the old measurement, okay? And this ratio, to describe the scale factor of the new shape to the old, use the ratio new over old. And I'm going to show you two ways that you can calculate the ratio here, okay? So let me move up just a bit here so that you can see all of my work. Okay, so it says the new length is changed to 3. What will the new volume be? Okay, so the new length is changed to 3 inches. Okay, so we know that the formula is length times width
could you come to the office,
times height. So the length, if you look at the picture, is 3. The width is 6. And the height is 10. So 3 times 6 times 10. 3 times 6 is 18. 18 times 10 is 180. So it's 180 inches cubed. Okay. Now, there's two ways that we can compare the new volume to the original volume or the old volume. Okay, we can use the two volumes. So we can do the new volume over the old volume. So up here, I'm going to calculate, this is the new, and then this is going to be the old volume. So once again, V equals length times width times height. And just ignore where I scratched out because we're doing the original. So we're going to do 12 times 6 times 10. So 12 times 6 times 10. 12 times 6 is 72. 72 times 10 is 720 inches cubed. Okay, so one way we can do this is by comparing the volumes. So that's what I'm going to show you here. And we can do, remember the ratio is new over old, so we can do 180 over 720. And of course, we need to simplify this to figure out what the scale factor is going to actually be. We can't say 180 over 720 because that can be simplified. And an easy way to simplify this is, well, they both end in 0, so I could do 10. But I notice if you count by 20s, anything that ends in 20, 40, 60, or 80 or double 0 is divisible by 20. So I'm going to divide top and bottom by 20 to make this easier. And 180 divided by 20 is 9. And 720 divided by 20 is 36. Now, think of a number that can go into 9 and 36 evenly. Hopefully, you thought of 9. So I can divide 9 divided by 9 is 1. 36 divided by 9 is 4. So the scale factor is 1/4. Now, so we can say the new volume is 1/4 of the original volume. And think about it. okay? The old volume was 720, the new volume is 180, so it was reduced in size, and 1/4 is less than 1, so we know that it reduced in size. Okay, now, if we compare the lengths, because we know that the new length is changed to 3, and the old length right here was 12. So we can say new length over old length. And now this one is much easier to simplify. What number goes into 3 and 12? Hopefully you said 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So we can tell that the scale factor is 1/4. And if the scale factor, if we only change one attribute, which we did, the length was changed from 3 to 12, then we know that the scale factor of the length is the same scale factor as the volume. So that's why we can use the volumes to find the scale factor, or we can use the lengths to find the scale factor. Now this is only going to work if we are changing one attribute. And that means you can either change the length, the width, or the height. Okay, that concludes part 2 of our notes. I hope you have a great day.